Okay. All right. So I'm just going to do this recording of this last problem because I really just kind of want to show you how to do it. There's a MyLab question like it. Um, but anyway, so we got a 14 tall fence that runs parallel to the wall of a house, distance of 18 feet. Find the length of the shortest ladder. Okay, so that's important, right? That's what we're trying to minimize. That extends from the ground to the house. And this line without touching the fence, I'm not sure what they mean by that because I guess it's kind of going to have to lay on top of the fence, but that's how MyLab words it. So I wanted to have it the same way. But anyway, so I have is a house, and then I got a 14 tall fence. There's the fence. Then I got this ladder coming like that. Oh, and it says that it's 18 feet from the house. Okay, so what I want to do is minimize the length of the ladder. So I guess we'll call that L. All right. So we've got a couple other things going on. I have a height that it's going up the ladder, and I've got some distance X from the fence down to the edge of the ladder. So I'm going to use the Pythagorean theorem. Right. And so again, what I'm actually going to do, like in the previous problem with the parabola, and I should say actually, I'm going to minimize L squared, not L, because then I don't have to deal with the weird square roots and everything like that. I just know at the end of the day, when I find my value, I've just found L squared. So then I just take the square root to get the actual length of the ladder. All right. But what I got here is two variables, which is trouble. So I'm going to need some other way to get my h and my x together. And I guess what I'm going to notice is anytime we have a shape like this, I should think about similar triangles. So I guess I'll say I'm going to go shorter triangle first. I'll say 14 is to x as h is to x plus 18. Then I'm going to solve this thing for h. And again, watch how I do it, because the algebra you want to be careful with here to not get yourself being too messy. I'm going to say h is 14 over x times x plus 18. All right, so then when I put this in for h squared, what I've got is, well, 14 squared is 196 over x squared times x plus 18 squared. That's your whole h. And then I've got this. All right. So now, to make this all work out nicely, I don't like big, long polynomials, right? Especially when we're going to get cubics and everything like that. So I'm going to think it's going to be easier that I factor out this common term, x plus 18 squared. And I'm going to call this 196 over x squared plus 1. All right. So when I find my f prime of x, it's going to be a product rule, with my a term being x plus 18 squared, and my b term being 196 over x squared plus 1. All right. So my a prime is going to be 2 times x plus 18. Then over here, let me just do a little bit of side work. I'm going to think about that as 196 x to the negative 2, which would make y prime negative, and watch how I'm going to do it. I'm going to call it 196 times 2. I'm not even going to worry about what that is. X to the negative 3. Anyway, so I do a prime b. Oh, I'm going to need more room, aren't I? Oh, shoot. I'm so sorry. I just f prime is 2 times x plus 18. And b prime, I'm just going to call this negative 2 times 196 over x cubed, which means my f prime of x is a prime b. You know what? Let's just do it over here. So a prime b, so I'm going to write this as 2 times x plus 18 times 196 over x squared plus 1 plus b prime a, which is minus 2 times 196 over x cubed times a, which is 18 minus x plus 18 squared. The reason I left it as 2 times 196 is because I know I'm bringing both of these 2's out, and I'm going to be dividing it anyway. So here, let me make that look a little nicer. And the other thing I can bring out is on x plus 18. Right, I want to set this equal to 0. I don't want big multiplication. I want nice factors. So on this one, I'm left with 196 over x squared plus 1. Then on this, I'm left with 196 over x cubed times I have one more x plus 18 left. So, all right, you'll see what happens. I'll distribute through that 196 over x squared, and it's just they're gonna go away, right? Right, so that's gonna be minus 196 over x squared minus 196 times 18. Oh, geez, I guess let me use a calculator for that. Which will be 3528 over x cubed. Again, your C. Those two guys kill each other. Then I can combine these two guys together, right? That's going to be, right, if you gave them both x cubed, that's x cubed minus 3528 over x cubed. So that means I can stick all that together, and I have 2 times x plus 18 times x cubed minus 3528 over x cubed. So where are my crits? Well, from there, I get x equals negative 18. Well, I'm going to throw that out because my x has to be positive, right? We see that here. I could have from down there So x is 0, but we can throw that out. We're left with one critical point. And x is going to be the cubed root of 3528. Let me just kind of get a approximation for that. Well, let's just leave it like that for now. Okay. Now, what they wanted was the length of the shortest ladder, right? So there's where we get the all right, but then I'm going to say my L squared, right? And I can just plug everything in here. Yeah, you know what? Let's approximate that. Three, 5, 2, 8 raised to the 1/3 power. 15.22. Right, so the ladder, which is what we were actually looking at, so L squared I'm sorry, let's plug it into the easier thing. The easier thing being that thing right there. And I'll just type all this in. All right, 15.22 plus 18 quantity squared times 196 divided by 15.22 squared plus 1. And I got 2037.31. But remember, that's the square of my ladder. So then my shortest ladder, L, is going to be the square root of that number. Which is 45.14. So yeah, one is to kind of set the problem up right, to notice that we actually do need the ladder to be touching the fence. I'm not sure what they meant by that. But really, I guess mainly all the little weird algebra stuff I did. I think you're going to generally find the things like I did here, right? And things like I did here. You're pretty much always going to be better at factoring things out than it is going to be dealing with the big, nasty polynomial. But anyway, there's that problem. So I don't know. Hopefully that's helpful. Thanks. How do I